stapled together. It's a little bit longer for notes.
Oh, it is.
Yeah, so there's just more in the notes. There's not more in the lesson. There's just more in the notes. Are we ready?
I'm ready.
I'm not asking like, are you awake and are you happy? Just are we ready?
Wait, today's the 11th.
Today is the Aladdin's Eatery.
I gotta write that on my notes.
Yeah, so plan book out real quick.
What if we know we're not gonna go there?
Well, that's fine, but make sure you got your homework written down. Did you write that down yet?
This Wednesday is May 4th.
Yes, this Wednesday is Star Wars Day. May the 4th be with you.
I want to go to the.
So, alright, let's check out our launch here. We're going to skip past this video. You guys know kind of what we're already talking about here. So, we have
This is so quick and easy. It's a no-brainer.
This has all the data. You can't argue with the data.
So, Misadventure and Data Girl are kind of having a disagreement. Which study should the airline put their money into?
Puerto Rico.
Misadventure says how many people flew to Puerto Rico on Tuesday, like this past Tuesday. And Data Girl says how many people fly to Puerto Rico on Tuesdays, like all Tuesdays. You got it, Emily? So Thomas, very good point. What's the difference between what Data Girl and what Misadventure is asking? Today is 5-2. You're trying to remember the date. Today is May the 2nd. Well, so you guys got to get here on time. If you're not here on time, our notes are always right here. So if you notice that you don't have notes, grab yourself a copy. What's the difference? There's one tiny little difference that makes a big difference in what we're actually asking. Bella, you beat Ethan out. Minutely. The S at the end of the Tuesday. Now, what does Tuesday becoming plural? What does that do? What do you mean more data? So is it just 2 of the Tuesdays or 3 of them or what?
No, it's every single Tuesday.
It's all of them. So if you were the airline and you were deciding what should I put my money into, do you think you should do research on just one day of travel?
No.
Why would that be an issue, Luke?
Because maybe there were.
Maybe what? What could have happened? What could have been going on that Tuesday?
Maybe there was like a parade or something, and people stayed home.
Yeah, maybe there was like a special event and a lot of people didn't travel, or maybe on the other side of that there was a special event and a lot of people did travel. So maybe this one Tuesday could be skewed. So it could be skewed one direction or the other. It could be skewed towards more people traveling or it could be skewed towards less people traveling. This has more data and therefore it is more, what do you think the word I'm going to use here is? Since there's more data, it is more, reliable, credible. Word I really like to use here, accurate. When you have more data, you have greater accuracy. When you have more data, you have greater accuracy. So we should probably trust Data Girl since, she is Data Girl after all. So first thing we're going to talk about is what are measures of center. So a measure of center, all it does, and I want you to highlight or underline or something here, all a measure of center does is summarize data. Measures of center make your life easier. The whole point of math is to make your life easier, and a lot of you are like, there's no chance. Math always makes my life harder. No, the point of math is to make your life easier. So when we talk about a measure of center, the main one that we talk about here is the mean. Now, mean has another name that it's more often, well, I don't know about more often, that it is often referred to. The mean is also the average. The way I remember this when I was a kid, the average teacher's mean. Now, at Phoenix, that doesn't really work, but that's how I remembered it as a kid. Mean is average. Average is mean. So, to find the mean, all we do is sum all of our data and divide by the number of data points. Hopefully we all remember this from elementary. So off to the side here on your notes, put equals average. So you make sure that you remember that's really just the average. You've got some space on your notes there. Where I'm talking about is right here, right off to the side here. Make sure this says average. Now, what about the median? Without looking at your notes, I'm looking ahead of us. Ethan, what's the median talk
It's like
about?
the middle or the center. Like it's the if all the numbers or information was in chronological order, the median would be like the center.
Yeah, if all my data, and I like that you started with that. If all my data is in order. So my data has to be ordered first, but median, I want you off to the side of median, and actually on your notes there's a really good spot to put that. What's a synonym that we could use for median to make it easier? Middle. It's just the middle. So to find the middle of an odd amount of numbers, that's easy. There's going to be one middle. What gets more difficult is finding the middle of an even amount of data, because check this out. -5, -1, 3, 6, 7, 8, 8, 9. My middle, if I start, and an easy way to find the median, cross one off the left, cross one off the right, cross one off the left, cross one off the right, cross one off the left, cross one off the right. Crap. Can I cross one off the left? No, because then I can't cross one off the right to make it even. So my median is both of these, but I can't have two middles. That doesn't make sense, Thomas.
You add them both together and divide them by 2.
So we essentially find the average, or just find out what's right between them. Right between 6 and 7 is 6.5. So what you're really saying is what is directly between those two terms, which define the number directly between them, that's the average. So whenever you have an even set of data, and guys, this, I tell you from experience, this is where people get frustrated with their digits homework. I would here put find average of middle two terms. This is really hard to write this way, so give me a second. I'm going to block the screen for a second. Find the average of middle two terms. And we'll do a couple examples with that today, but we just then need to find the average of those middle two terms. So for speed, I'm just going to keep working straight down our notes. So Yellowstone National Park, anyone been to Yellowstone before? Why is it famous?
Geysers?
The geysers. What's a geyser?
Water thingy.
Yeah, why does a geyser happen?
Heat in the ground.
I know.
Heat from where?
The ground.
No, not
Lava.
Thomas?
It's heat from the center of the earth is like right next to the geyser, because there's heat there.
It heats it up.
Heat creates pressure. Pressure has to escape, otherwise you end up with an explosion. Over time, geysers have formed, which is essentially an escape vent for all this hot air and hot water vapor. So water shoots up out of there, and it's kind of dangerous, so you want to stay kind of far back. But, so this is a line graph of how often the geyser erupts. So the time interval between eruptions. So here this would be like 5.5 minutes between eruptions. 6 minutes, 7 minutes between eruptions. That happened twice. 8 minutes happened once. 8.5 minutes. And then 10 minutes between eruptions happened twice. So find the mean and median intervals between eruptions. What do you think we should do before I would be able to find the mean or median?
Just them in order. Well, they're in
So you said place them in order. Ethan said they're already in order. But I kind of agree with what you said. But it's not about placing them in order. It's about, Oriana? Write them out. So the first thing we have to do is write out the points that you have, the data values. So this is a 5.5. My first value is a 5.5. Then I put a comma to separate my data values. Then I have a 6. And then I have 7 happens twice. So we have to write down 2 7s. 8 happens once. 8.5 happens once. And then 10 happens twice. How do I find the average? Orion?
We add these all up and then divide by 2.
So really what I'm going to do to find average
No, divide by the number.
is add these all up. I was going to get to there. Thank you for catching yourself. So we're going to add these all up, but then we divide by how many data points there are. So first I'm going to write out what my sum is. It's 8. It is not 8.
No, I think he's talking.
I don't care. I know what he's talking about. My sum is not 8. I'm looking for the sum first. Quit jumping ahead. So 10 and 10 is 20. 34, 42, then 50.5, then 56, 62 for a sum. So my sum is 62. Count how many data points we have. We've got 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 data points. And then what is our average time here? And by the way, let's use mean so that you get used to seeing that word. So don't use average, use mean so that we get used to it. If we do 62 divided by 8, what do we get? Cassie?
7 and 7.5.
7.75?
It's, yeah, 7.75.
So since it's time, I'm going to use 7 3/4 minutes. Now to find my median, that's my middle value. Do I have an even or odd, bless you, do I have an even or odd number of data points here? Even. So this becomes a little tricky. Since I know I have 8 data points, think about chopping that in the middle. The middle would be 4, right? So I know that my 1, 2, 3, 4th point from this direction and 1, 2, 3, 4th point from this direction, both of these are my medians right now, but I can't have 2 medians. So what is my actual median? 7.5. So since the average amount of time it takes is 7 3/4 of a minute, and the middle value of my table is 7.5, what could you infer about how often the geyser erupts? You have a hand, right, Luke? Because I'm starting to wonder. Thomas, you had your hand up?
It's 7.5 minutes.
Yeah, so we could say this erupts about every, I'm going to say 7 to 8. I'm just going to give it a range. So there's about 7 to 8 minutes between eruptions. It's okay to give a range.
I have a confession to make. I didn't go to Yellowstone. I thought I did. I went to Yosemite.
You went to Yosemite. Yosemite is slightly different. You know what, Karina? I think we will all forgive you since you were honest with us and you told us that you did not, in fact, go to Yellowstone. Was it that the more you thought about it, you realized you hadn't seen geysers? Or yeah. So, try this one out. Now we have more geyser data, but now we're dealing with the height of the eruption. Some don't go very high. It's like, okay, that was it. Some go super high. Depends how much pressure it's able to store first. So I want you to figure out the mean height here. So you can work with the people close around you, but I need you to find the mean height there. Take a minute or two.
did calculator.
Okay, that makes
189.
This is my breakfast and my dinner.
That's really sad.
What? Your breakfast and your dinner?
Is it today's dinner or yesterday's dinner?
Yes, yesterday's.
Well, I'd say if it's today's dinner, you're kind of working ahead of yourself. Guys, come on. I had it even written on the chalkboard and no one was going to ask me.
Ask you what?
I need to pass out papers.
Oh yeah, don't forget to do that. Do that.
Jeez, you almost let me forget again.
Yeah, we're testing you, Mr.
I stink. Thank you, Abby. Brennan.
I've gotten something so far.
You must not have turned any in. Mean. It's on your paper. What is the mean height of the guy's eruption? You could find the median, but that'd be a little bit more difficult because then we'd have to reorder our data. So, cards. Isaiah, what information do we need to find the mean? The sum of all my data. So what'd you get for your sum?
Wait. 189. Yeah, like he said.
189. Can anyone verify that? Yeah? How many data points did we have? 9. What do we get when we divide this? 21, which I hate that was the answer.
I hate that.
So, if you were there, hey, hold up, let's relate probability to this. If you were there and you saw an eruption and somebody was like, wow, that was a 50-foot eruption, how likely do you think a 50-foot eruption is?
Not very likely.
Not very likely. Pretty unlikely, especially when we look at this table, our list of data. There's no 50-foot eruption. It would look like that's a very unlikely occurrence. So that'd be sweet if you were there for that. That'd be, you would have been lucky or very fortunate. So, range. Anyone ever been to the driving range or shooting range or things like that? So why do you think they have to have designated ranges for things like that? Why is it called a range?
Because it's like a distance. It's a distance or some stretch of land/track that you use for doing something. Like a shooting range is a designated area for shooting.
So shooting or golfing or any of these ranges that you go to, it's a designated space so that they know where you're going to start. They say this is where you hit the golf ball. This is where you shoot your gun. And they know where it's going to end because either they know you can't go, like golf ranges, they know how far you can hit a golf ball. You can't hit a golf ball 600 yards. It's just not physically possible. Unless, we could make like a super duper driver with some special metals and yeah. Okay. So moving on from movies, shooting ranges, they would normally have like a hillside or something that your bullet would end up going into. But the point of a range is it's the entire distance of the data, or it's the spread of the data values. So to talk about the range, all it is the difference between the greatest and the least. How wide is your data set, essentially? So when we talk about range of temperatures, Ohio has a pretty big range of temperatures. If you look at our range in a year, how low do you think our lowest low temperature was?
-42.
Like -20, right? Probably. If we talk about wind chill.
-32.
At actual temp or wind temp?
Yeah, actual temp.
Okay. So -32 has been a low recorded temperature. How high do you think we get in the summer? 100, right? At least 100. A lot of times over 100. So our range in temperature would be well over 100 degrees. Now go to California. How cold do you think it gets in California?
Like 60 degrees.
Yeah.
I always watch people on YouTube and they're always like freaking out. They're like, oh my god,
It's so cold, and it's like
like
55 degrees.
If you're in Ohio, we want that.
So, So that range would be much less because they would have a much higher low value. So all you gotta do is figure out which is my lowest value, which is my highest value. You do not have to put your data in order for this. You just have to identify what's the low point, what's the high point, and then you take the difference between them. Now remember, if your low point is a negative, that's not going to help them with any sound. If your low point is a negative, when we do, hey guys, hi, I'm up here, whatever they're doing isn't going to help them and it doesn't affect you. If your low point is a negative, remember that when we subtract a negative, it ends up being addition. So we really add the values, and we get a range of 16 here for this data set, or we can find our range of temperatures or whatever else. Now, quartiles, what stem or root do you hear in the word quartiles? Quart. What does quart mean? Four. So quartiles are going to break this up. I want you to highlight or underline or star 4 parts with the same number of data values in each part. Guys, that's huge. A lot of people don't get this. Same number of data values in each part. Which is why sometimes my number that I have will go into the quartile. Sometimes it will not be part of the quartile. This is where things get a little complicated. So here with my data set of -5, -1, 4, 7, 8, 8, 11. I break my data up into fourths. I break it right down the middle. So I have 3 on this side and 3 on that side. So is that 7 part of my left or my right? No. So it right now is being used as the center. Then when I break up my left part in half, so I have 1 on the left, 1 on the right, is my -1 on the left or the right? No, so it's being used, and we call that my first quartile. It's like my first divider, or like my value that cuts it. And then I do that again on the right side, and that 8 is what we call my third quartile. My median value is the second quartile. So you might want to point out that this median, that's why we have to be able to find our median. The reason we find our median is to work towards finding these quartiles. And then the interquartile range, which we will almost always abbreviate as IQR. Inter, what does inter mean?
Into.
Between. So this is the range between my quartiles. Interquartile range is the range between our quartiles. So we take our third quartile minus our first quartile. So here we had the 8 and the -1. So we take 8 and we subtract away -1 and we get 9. So my interquartile range here, my IQR is 9. Any questions on range, quartiles, or interquartile range? Yeah. Yeah, so thank you. I forgot to go over our week. So let me grab my planner. Today we are doing 15.1, maybe 15.2. Tomorrow is our mastery. It's only 17 problems. I think you guys will get done in one day. I have high hopes that you'll be done in one day. So then Wednesday, Thursday, we will be having class, moving forward with stuff. And probably still Friday we'll just have class and try to wrap up this chapter. And then we'll probably, I know this stinks, we're probably gonna have to take this chapter mastery next Monday because it's our last, that's our last normal class day of the year. Yeah, that's our last normal. So guys, we're in May. We have 4 weeks of school left. Not even. We have 4 weeks minus a day. So check it out. It's much easier if not all of us talk at the same time because in 30 seconds I'm gonna start teaching again. This is this week. So I'm saying our test would be on this day, the 9th, for chapter 15 for this chapter. But guys, this is easy content. You learned a lot of this last year. So then this is May term, 10th through the 13th and the 16th. 17th through the 20th is travel, and these 4 days are our last 4 days of school. We do our final MI Olympic stuff there. We do our egg drop there. We it's weird class days. That's why I say Monday is your last normal class day. So, any questions on IQR? All right, cool. It was already captured. Clear. So, here we go. A box and whisker plot. Who's ever seen a box and whisker
I
plot?
learned this in like 5th grade.
Yeah. So, here's what I need you to label on here. Here's what and you guys might not have a ton of space, because I mean, this is your notes, but I need you to label this first point is my minimum. It's my lowest value in the data. So what do you think this point is? The maximum, the highest point in the data. What do you think this point in the middle of the box is? The median, the very middle value of the data. Which then leaves my point at the end of the box and my other point at the end of the box. And as Thomas just helped us out, this is quartile 1 and this is quartile 3, because really your median is quartile 2. Yeah.
If that's the median, why does 170 to 190 bigger than 155 or something to 170?
That's a wonderful question. So our data is not always evenly distributed. So if your data was in a list of, here's your data, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That would be a very evenly distributed data set. But that's not ever what happens. So people say, here's your data. 1, 5, 19, 14, 37, 26, 18, 42. Like, it's all these random numbers. So when we put them in order and we start to break it up into chunks, each of these chunks, this space right here is 25% of the data values. This space right here is 25% of the data values. Because when I break up all the data, so what I do to begin with is I take the data as a whole, the entire thing, and I chop it in half. And I say the left half versus the right half. Then I chop my left half in half, and I say my first 25%, my next 25%, my next 25%, and my next 25%. That's how a box and whisker plot works. So that's why it's not going to look even. And a lot of times, there's a big distance here between the first quartile and your minimum, or your third quartile and your maximum, because sometimes we have outlier points. If we have an outlier, I mean, we could have a point as like wherever as far up here, depending on how hot the pool temps get. Now, because this is temperatures, we're probably not going to have a temperature of 400 degrees. That's way above boiling. That would be vapor. That would not be a liquid temperature, at least not for water. We probably won't have a temperature of 40 degrees. No one's going to get in a hot spring if it's 40 degrees. I don't think that would make sense. So that's why this data is a little closer together. So when we look at finding the range and the interquartile range for these temperatures, well, if I need to find the range, what do I need to find the range? What two values do I need to find the total range? The what?
Maximum and minimum.
The maximum and the minimum. Your range, if you paused and didn't know how to find it, you need to write this down. It's the max minus the min. So my range here, well, I need to approximate what this max is. What's the highest this temperature could possibly be? 200. Ooh, nope. What's boiling? 212 is boiling. So this could not be boiling, but also we see that each of these gaps is 10. So if each of these is 10, that's maybe like 202. We could say that's maybe 202 degrees. And then my minimum temperature, 144. Yeah, if I were to try to guess, I'd probably say 144. So what is my range of temperatures there?
58.
Thank you very much. 58. That was the address of our house and college. Yep. but all I'm talking about is the range. So I don't care actually degrees Fahrenheit. I'm just saying it's 58 degrees is the range of temperatures. You could say you're Fahrenheit because you're dealing in degrees Fahrenheit, but all we need to know is the range is 58. Now my IQR, my interquartile range, how do I find that? Cassidy?
The interquartile number 1, interquartile number 3.
Yeah, it's quartile 3 minus quartile 1. And we use the little numbers just as like descriptors. So this is quartile 3 minus quartile 1. So my quartile 3 is at the top end of my box.
Like
180.
189.
Yeah, it might be as close as 189, so we'll give it that. And then my quartile 1 is my other end of the box. 155. It looks like it's right in the middle. When I do that subtraction, I get 34. So what that tells me is all of my temperatures vary about 58 degrees. But my interquartile, my main 50%, because when we talk about the interquartile, this is my main 50%, the middle 50% of all things that are happening. That main 50% only has a variability of 34 degrees. So when it talks about describe the variability, that's what we're talking about. The main 50% only has a range of 34, whereas all data has a range of 58. So take a second, jot something down right there. If this was me answering it, I'd say the main 50% of values then I might say where all the data ranges 58 degrees. Because that is a pretty big swing in temperature.
Oh yeah.
Even 10 degrees in water temperature is a pretty big change.
Air temperature too. That's like 30. Just a
Yeah, but water temperature especially because it will suck the heat out of you. So, try this out. I need you to first determine what is my median, what is my first quartile, and what is my third quartile, to then be able to find our interquartile range. So remember, we're looking for interquartile range. To do that, we need all three quartiles. I want you to try it on your own, but I'm going to start my work up here. Try not to look up here. You can if you need to. Crap. Make sure that when you go to put them in order, you don't forget any of them. I just had that happen to me. So the first thing everybody should be doing here is putting their data values in order. Yeah? Keep trying. Give it a second. The first thing everybody should have done is put their data in order. If you're struggling, here it is in order.
So if you need to mark them off on each side, like there's two left and they're the same number, you just
Wouldn't it just be that number?
Then what number's right between the same two numbers?
25.
So when we're looking for the median, now this is when I said mark off, but you don't have to actually cross out. If I count one from the left side, one from the right side, I can just put little dots. One from the left, one from the right.
No, it's 25.
I only have 6 data values, so my median get stuck right between here. But can I make my median 25 and split it between them and have an even number, or like the same number on the left and the right? Yes. So here, my median, or my quartile 2, is 25, but that is not one of those 25s. It's a number between them. So I'm not using either of those 25s. I'm actually right between them.
Which is the same?
So then, yeah, because what's right between 25 and 25?
Yeah.
Well, 25
So
is.
you're just adding another 25 to the data.
No, we're not putting another number in. We're saying the middle of our data is 25. There's not another point. We're just saying the middle is 25. So now for quartile 1, look only at the left side. How many data points? 3. Can I find a perfect center? Yes. So this becomes my first quartile. On the right side, can I find a perfect center? Yes. So this becomes my quartile 3. So if you were drawing a box and whisker plot, just give me your attention for just a second. If you were drawing a box and whisker plot, you would have a point at 6, a whisker over to 23.5, which is where your box would start. Your box would go all the way up to your quartile 3, and your quartile 2 would be right where that center of the box is shown. You'd have this other point at your quartile 3, and you'd have a whisker out to your final point of 32.5. So our interquartile range, well, I just drew it like that, but if we were on a number line, it would probably look a little bit different because 6 is pretty far away, so this would actually probably stretch pretty far out. But then to find the interquartile range, we're just dealing with what's the difference, or what's the width of my box is essentially what it's asking. Yes, but I will probably give you a number line, and you just put your box and whisker on the number line. Yeah, it's hard when you have to draw your own number line. I know that. So then to find my IQR, I just take my 27 minus my 23.5. Remember to borrow. A lot of people try to tell me this is 4.5. It's not. It's 3.5. Because they think the difference between 27 and 23 is 4, and then they look at the half. But it's 4, and then I take away the half. So, interquartile range is 3.5, and that would be feet, if we care to label that.
Isn't it important to label?
Yeah.
Yeah, you don't want to leave your numbers naked.
That would be
We will not be getting to 15.2, so I'm going to do a tiny little shift here. And 15.2 falls on tomorrow, but I will go ahead and assign it tonight, like post it. So if you want to work ahead, you can.
Is it basically the same as this?
Not quite the same. It deals more with like inferences that we can make based off our data. Hey, hold on, I got a couple minutes left. I was just letting you know we're not going to get to 15.2. I still have 4 minutes, so please don't pack up. You hurt my feelings when you pack up early.
Yeah, that just makes you seem like you really want to leave Mr.
Yeah, and who wants to leave my class?
I know, right?
So, Misadventure and Data Girl are back together again. They're having another argument. Well, not argument, a discussion, I guess I should say. Adults like to have excited discussions. So, find the median and the range for each airline. So, here's my challenge. Everybody sitting in this area, you are Beta Air. Everybody over here, you are Park Air. We gotta find the median and the range for each of them as fast as possible. Find the median and the range for each airline.
Your box is in the way of the 400.
I'm pretty sure.
Yeah, well, it's on your paper. Oh, it is.
400.
what did you want us to find?
Median and range. So median being the middle value, and range being the difference between the min and the max. Could we abbreviate median with M?
No.
Never.
Tons of other M's.
Mean, median, mode, but like there's too many M words. You have to at least use the first 3 letters. MED. And at that point you could just write the whole thing if you want.
Well, what if it's medicine?
Huh? Yeah, we're not going to ask what's the medicine of the data set.
Yeah, it needs to take some median.
So I could look through my beta error. Beta error, who's got your median for me? Beta error, who's got median? Bella? 402. Because if I look, 399 is my lowest. 400 is my next lowest. 402 is in the middle because I know then that I have 2 highest values. So my median is 402, which was actually my Boy Scout troop. What's the range in the data? Cassidy?
223.
How'd you find it?
I did 722 minus 99.
Yeah, so she's going to take her lowest value that she identified and the highest value that she identified, find the difference between them, and you get 323. Park error. Who's got my median value? You?
428.
428. I look for my lowest. 398 is my lowest. I look for my next lowest, and 409 is it. So my median is 428. And then because I already identified the lowest value, I look for the highest, which is 465, and my range there is.
67.
So now wait a minute. Which airline would you travel on, Beta or Park? Beta? Why'd you choose Beta? The median is lower for Beta, right? But their range is huge. Does the middle data point really tell you that much? What it tells us is half of the prices are lower than this, and half of the prices are higher than this. But what would be better to look at than the median? Yeah, the range is important, but what's probably the best measure of center to look at a whole?
Average.
The mean, the average, that's often what tells us the most about a data set. If we looked at our average prices, it'd be easier to make a comparison. Thank you guys very much. We'll pick up tomorrow. Actually, no, we won't. We'll take your mastery tomorrow. We'll pick up here Wednesday.
Oh, yeah, mastery.
Muchas gracias.